product.
All right, so
But it's formed. So it has to. Your leaving group is the BR.
okay, so let's draw what we have here. So we have this guy here, this phenyl group. We got a hydrogen here, we got bromine here, we got a hydrogen here, CH3 here, CH2, CH3. So we're supposed to draw the product of this reaction, and we're reacting this with that, and so we need to get the product of this. And the name of this compound is 1R 2S 1-bromo 2-methyl 1-phenylbutane. Right? So we want to give the product that will be formed, right? And we want to make sure we draw the correct stereoisomer of the product. So do you have an idea what is going to happen here?
Something's gonna be
Okay. So you're talking about substitution, right?
Mm-hmm.
But we're going to get an elimination in this case. So we're going to have an elimination.
So the bromine is gonna be eliminated by the oxygen.
Okay.
Well, the whole group.
Okay, so how are we doing the elimination? Do you know?
Through a E2.
That's right. So we're going to be doing an E2.
It's gonna be like an instant change.
The geometry is going to be anti-periplanar.
Yeah.
So what we have to do is we got to rotate this, all right?
Mm-hmm.
Remember that whenever you have single bonds, whenever you have a single bond,
Mm-hmm.
there's a rotate. You can get a rotation, right? So what we want to do is, now you see the this wedge here.
Mm-hmm.
We just want to rotate this slightly. We want to rotate this so this wedge and this wedge are in the same.
Okay.
And this here is supposed to be on the dash, right?
Yeah. So these two switch and these two, or just these two switch, not these two.
Yeah. So wait, which two did you say are switching?
These two.
So imagine we take this part, this hydrogen, and we just like
Rotate it.
so if we rotate this guy here,
Yeah.
this guy will rotate here, and this guy will rotate here, right?
Yeah.
So that's what we want to do first. Alright, so we're just gonna switch these up a little bit. So we want to get the hydrogen here, right? We want to get the CH3 here, right? So the CH3 is going to be here, right? And this group is going to be the CH2, CH3. Alright, the reason why we're doing this is because the hydrogen has to be anti-periplanar to the leaving group, right? So we're going to have this base here, and it's going to take this hydrogen here. We're going to form a, this is going to come down here, and this group is going to get kicked out. Cool. So then we're going to be left with our product, which is going to look like
But
this.
here, I don't think we don't have to show like the dash wedge. I think as long as we.
Sorry, what did you say? Okay, so this should be the product right here. Or this is the product.
So it'd be like this. Or wait. No. So this would be not here. But what goes here and here? Nothing?
Nope.
Like that? Right.
Perfect.
Oh wait, but then I need the double bond on the phenol, right?
Just really fast before we jump into the rest of the stuff. So remember this. So if we're talking about substitution, we're simply replacing something with something else.
Yeah.
If we're talking about elimination, something is going to get removed.
Yeah. And it's being replaced by double bond.
Let's go over here. If elimination means that we're removing something and we're forming a double bond, but there's two different ways it can happen. E1, E2. E1 is stepwise, we're going through a carbocation. E2 is concerted. It's one go. Substituting one group with another group, there's two ways it can happen, SN1, SN2. So you can see here, right, for the elimination, we're starting off with an alkyl halide.
Yeah.
And usually we're starting off with alkyl halide, and then we're going to end up with an alkene, right? For the substitution, alkyl halide, usually, you add in a nucleophile, and the nucleophile displaces this other group.
Alright, gotcha.
Cool.
Alright. And then in terms of inversions, does that happen where the halide is detached, or is it to the other one?
Is this for, what is SN2?
This is still E2. Right?
So they have to be anti-periplanar. The hydrogen that the base deprotonates and the leaving group, they have to be anti to each other.
Okay.
Right?
Okay. I got what you're saying. I know what you're saying. The hydrogen. Wait, say that one more time.
So the hydrogen that the base is going to deprotonate has to be anti to the halogen